Are you always asking for the ball on the three-point line, but can never actually hit the three? Well, this is the video for you. After watching, we'll turn you from this to this. Hello and welcome. Today we will be discussing how to optimize your three-point shot using kinematics and the equations of motion. NBA players must be experts in physics if they're consistently knocking down jumpers. The three key factors necessary to optimize the three-point shot are launch height, launch speed, and launch angle.
Looking at my attempt, we can see that I released the ball at a launch angle of approximately 55 degrees and a launch height of about 2 meters. Toni's launch height is higher than mine, which allows him to shoot at a lower launch angle in comparison to my shot. But how can we find the optimal launch angle and launch speed at a specified launch height? That is, what combination allows for the greatest margin of error for the ball entering the basket after a three-point shot? The projectile motion equations are as follows, where VO is our launch speed, which we can relate to the launch angle by plugging in VXO equals VO cos theta and VYO equals VO sine theta. We will also let XOYO be the origin so that we can cancel these components. The other variables are constants apart from t, which we let equal a second after the ball is released, since this is the portion of time that we care about.
Letting launch height equal 2 meters, time equal 1 second, which is approximately when the ball is released at the initial velocity and the angle theta, we arrive at a curve.
This curve is generated by plotting the launch speed by the launch angle for trajectories that will result in a distance covered by the ball that produces a basket. Launch angles and launch speeds vary from 35 to 70 degrees and 7 to 10 meters per second respectively. The curve shows us the possible combinations of speed and angle that produce a basket with the thickness of the curve corresponding to the margin of error. Clearly, the greatest margin of error for a player is given by a launch speed of approximately 7.8 meters per second and a launch angle of approximately 50 degrees. How well do our results for an optimal angle match up to real-life NBA players? We see here Stephen Curry releases the ball at an angle of elevation of approximately 48 degrees. If this three-point shot enters the basket, then we can look to our plot to determine the speed that Steph releases this ball at. Of course, he knocks down the shot. Matching up a 48-degree angle of elevation on our plot to its launch speed, we see that Curry releases this ball between 7.8 and 7.9 meters per second. This is very close to the optimal angle and speed that we determined, which explains why Steph can knock down these shots so consistently. We can also plot the angle that the ball makes with the rim on its descent into the basket versus its launch angle. There's clearly a linear correlation between these two variables. If the optimal launch angle is 50 degrees, then this would correspond to an entering angle of about negative 40 degrees, which leaves lots of extra space for the ball to enter the basket and thus the greatest margin of error allowed, which agrees with our previous plot. Hopefully you have taken in some of our key points on this episode of Sports Science, and will go to the gym and splash your first three-point attempt. Remember to keep your launch angle of elevation near 50 degrees, to jump high in order to align your release height near parallel to the rim, and to put enough force into your shot to release the ball near 8 meters per second. Thank you so much for watching, and we'll see you next time when we cover the science behind shooting a penalty in a soccer game.